Whether you're a tech enthusiast, industry professional, or just curious about the future of AI Agents Unleashed will keep you informed and inspired. Buckle up and get ready to unleash the potential of AI.
Hey everyone, welcome back. Today we're diving into something pretty cool. Composition of experts. CoE. Sounds kind of complex, right?
It can be, yeah. But it's also super interesting and potentially a really big deal for the future of AI.
You always say that. But okay, I'll bite. Convince me. What's so special about CoE? What is it even?
Well, think about it like this. Right now, the big trend in AI is these huge language models, like ChatGPT, right?
Yeah, those things are everywhere.
Exactly. They're powerful, but they're also giant, like monstrously huge, and that comes with some serious drawbacks.
Drawbacks like?
Well, for one, they're incredibly expensive to develop and train. Like, we're talking millions, even hundreds of millions of dollars.
Whoa, that's a lot of cash. No wonder only the big tech companies can really play in that space.
Right. And it's not just the money. It also takes a ton of energy to run these models. Not exactly environmentally friendly, right?
Not ideal.
Yeah.
So where does CoE fit into all of this?
CoE is like a totally different approach. Instead of one massive model, you have a bunch of smaller, more specialized models, like a team of experts.
Okay, I'm picturing like a brain trust, each expert with their own unique skills.
Exactly. You could have an expert for math, one for understanding legal language, one for writing poetry, you name it.
So it's like a dream team of AI, ready to tackle any problem. I like it. But how does it actually work? Do all these experts just shout out answers at the same time?
Not quite. There's a router model that analyzes the incoming request. And based on what it sees, it routes the question to the most relevant expert.
So it's like a super smart switchboard operator connecting you to the right department.
Exactly. So instead of having this one giant model trying to do everything, you have these smaller, more focused models working together.
Okay, I'm starting to see the appeal. Seems a lot more efficient.
It is. And because each expert model is smaller, it's much faster and cheaper to train and update.
So CoE could be the key to making AI more accessible to smaller companies, researchers, maybe even individuals.
Exactly. It's like democratizing AI, making this powerful technology available to everyone, not just the big players.
That's a pretty powerful idea. But tell me, can CoE actually compete with those massive models in terms of performance?
That's the really cool part. In some cases, it can actually outperform them, especially for tasks that require expertise in multiple areas.
Give me an example.
Sure. Imagine you need to translate a technical document that also has a lot of legal jargon.
Okay, sounds pretty complicated.
Right. With CoE, you could have a translation expert, a technical expert, and a legal expert all working together, each contributing their specific knowledge.
Like a multidisciplinary approach to AI. I like it.
Yeah.
But wouldn't that create a ton of overhead? All that communication between experts?
That's where things get tricky, yeah. Managing all those experts and making sure they work together smoothly is a big challenge.
Right. So how do you actually implement a CoE system?
Well, one of the research papers you sent over dives into a specific CoE system called Samba-CoE. It uses a whopping 150 individual expert models.
150, that's a lot of experts.
It is. And get this, each of those expert models is based on something called Llama 27B.
Okay, I'm assuming that's some kind of AI model.
It is. And when you add up all the parameters from all those experts, this system has over 1 trillion parameters.
1 trillion. I can't even wrap my head around a number that big.
It's massive, yeah. Like a super brain working together to answer your questions. But here's the catch. Running something that complex isn't easy. You need some serious hardware.
So not just any laptop can handle this, huh? What kind of setup are we talking about here?
They actually use something called the SambaNova SN40L. It's a Dataflow accelerator, specifically designed to handle the unique challenges of running large CoE systems.
Dataflow accelerator. Okay, now you're just using fancy words to intimidate me. Break it down for me. What makes this hardware so special?
Think of it this way. Traditional computers are like city streets. Lots of traffic lights, intersections. It all slows things down.
Rush hour traffic. I feel that.
Right. But a Dataflow accelerator is like a superhighway. Data just flows smoothly and continuously with no bottlenecks.
Okay, that's a pretty cool analogy. But what about the memory wall? We talked about that earlier. Isn't that still a problem for running these massive AI systems?
It is. But the SN40L has a clever solution. It uses a 3-tier memory system. It's like having a filing system with different levels of accessibility.
So, like super organized storage.
Yeah. The most frequently used data is stored right on the processor itself for lightning-fast access. Then there's a higher capacity, slightly slower memory pool for the active expert models.
So it's like having the right tools and resources within easy reach rather than having to dig through a mountain of data every time.
Exactly. And then finally, there's this massive archive of all the other expert models, ready to be swapped in whenever needed.
Sounds incredibly efficient. So this SN40L really seems to be changing the game for CoE.
It's definitely a big step forward. By making it possible to run these large, complex CoE systems efficiently and affordably, it could really open up a whole new world of possibilities for AI.
I'm getting pretty excited about this CoE stuff. But before we get too carried away, I want to understand how it actually works in practice. What are some real-world applications of this technology?
Well, that's a perfect segue to the next part of our deep dive. We'll explore how CoE is being used in areas like healthcare, finance, even climate modeling.
All right. I'm definitely sticking around for that. Okay, so color me impressed. This SambaNova SN40L sounds like a real beast.
Yeah.
But does it actually live up to the hype? I mean, what kind of performance are we talking about here?
Oh, it definitely delivers, big time. The research paper you sent had a bunch of benchmark tests, and the SN40L just crushed it. Compared to traditional systems, even those fancy GPU setups, it's significantly faster.
All right, now you've got my attention. Spill the beans. How much faster are we talking about? Like, give me some real numbers.
Well, take this one operation. It's called Flash FFTCon. It's really important for processing long strings of data, like for language processing or analyzing time series data.
Okay, yeah, I remember that from the paper. It was a real bottleneck without the SN40L.
Right. But with the SN40L, they saw a 13x speed up. 13 times faster. It's insane.
Whoa, 13 times. That's a game changer, especially for those AI applications that need to crunch massive amounts of data.
Exactly. And it wasn't just a fluke with that one test. They saw similar speedups across a whole bunch of tasks, like both for training new models and using them to make predictions.
So it's not just some theoretical improvement. It actually translates into real-world gains. That's awesome. But I'm still kind of curious about Samba-CoE itself. Like you mentioned, it uses 150 individual expert models, each based on Llama 2 7B. What's so special about Llama 2 7B? Why that one?
Well, a couple of things. First, it's relatively small and efficient, which is super important when you're dealing with a system as complex as Samba-CoE. You don't want it to be bogged down, right?
Right, makes sense. But it's still powerful enough to handle the tasks.
Oh, yeah, absolutely. Despite its size, it's still very capable. And the other cool thing is that it's open source, so researchers and developers can mess around with it, modify it, make it their own.
So it's like a versatile building block for creating custom CoE systems. That's clever. But could they have used a different base model? Or were they stuck with Llama 2 7B?
No, they could have used something else if they wanted to. The idea of CoE isn't tied to any specific model. You could use all sorts of models, even ones with different architectures. It just depends on the task you're trying to accomplish.
So it's really about the principle of breaking down a big, complex problem into smaller, more manageable pieces, and then bringing in the right expert for each piece.
Yeah, exactly. Like assembling a dream team of AI specialists. Except this team can work on, like, a zillion things at once.
I like that analogy, a dream team of AI. But of course, managing a team that big, even a team of AI, can't be easy. How does Samba-CoE decide which expert to send a question to?
Ah, good question. Remember the router model we talked about earlier? That's the key. The router is also based on Llama 2 7B, but it's been specially trained to analyze incoming requests, kind of like a triage nurse figuring out where to send a patient.
So it's looking at the request and saying, okay, this one needs the legal expert, this one goes to the poetry expert, like that.
Yep, that's exactly it.
Yeah.
And this is where CoE really shines compared to some other approaches. Like, imagine you have a question that needs expertise in multiple areas.
Oh, okay. Give me an example of that.
Okay, how about this? You want to write a poem, right? But you want it to be about a complex scientific concept.
So you'd need an expert in poetry and science.
Exactly. With CoE, you could actually route that request to both experts, let them collaborate on a response. It's pretty cool.
Wow, that's pretty neat. It's like having different parts of a brain working together seamlessly. That's really interesting. But how is that different from, what was it called? Mixture of experts, or MoE. I remember seeing that in the research.
Oh, that's a great question. With MoE, the experts are actually still part of one big, giant model, so you have to train them all together, which can be a real pain and super expensive.
Right. We were talking about those crazy training costs before. Yeah, CoE sounds a lot more manageable and flexible.
It is. Each expert in CoE is completely independent, so you can swap in a new, improved expert whenever you want, without having to retrain the whole system. That makes it much easier to keep everything up to date and take advantage of the latest breakthroughs.
That modularity is really appealing. It's like having a computer where you can upgrade the parts as you go, rather than buying a whole new machine. I like that.
Hmm.
But even with all these advantages, there must be some challenges, right? I mean, managing all those independent models can't be a walk in the park.
You're right, it definitely takes some serious effort. The biggest challenge is probably managing all the communication between the experts, making sure everything flows smoothly.
Yeah, I can imagine that could get pretty hairy with 150 experts all trying to talk to each other.
Yeah, it's a bit like conducting an orchestra, making sure every instrument is in sync. But that's where the SN40L really shines. Remember that three-tier memory system we talked about?
Yeah, the super organized research library, that was a good one.
Right. Well, that system is designed to minimize data movement and make sure that the right information gets to the right expert at the right time.
Yeah.
Like having a team of super efficient librarians who can instantly fetch any book you need.
So it's not just about having the right experts, it's about having the right infrastructure to support them.
Yeah.
I get it. But, okay, I have to ask, how does all of this translate into real-world performance? We talked about speedups on those benchmarks, but how does Samba-CoE actually stack up against the other big players out there?
Well, they actually compared it head-to-head against two of the most powerful GPU systems out there, the NVIDIA DGX A100 and the DGX H100. The ones a lot of the big AI labs and companies use.
Oh, wow, so the big leagues. And how did it do?
Let's just say the SN40L wiped the floor with them. It was significantly faster at running Samba-CoE than either of the DGX systems.
Seriously. Come on, give me some numbers. How much faster are we talking?
Well, for example, they did this one test where they were generating short sequences of output. Think of it like completing a sentence. The SN40L was more than 6 times faster than the DGX A100 and over 3 times faster than the DGX H100.
Whoa, that's a serious beatdown. And I bet the advantage was even bigger when they were generating longer outputs, like paragraphs or even whole documents.
You know it. As the output length increased, the SN40L just pulled further ahead. It was over 4 times faster than the DGX A100 and over 2.5 times faster than the DGX H100.
Dang. And this was all on a single SN40L node, right?
Yeah.
Not a whole cluster of servers like you need for those DGX systems.
Yep. You can get those amazing performance gains with a much smaller footprint and probably at a way lower cost.
So CoE, paired with hardware like the SN40L, could really level the playing field, give smaller companies and research groups a fighting chance to compete with the big guys. That's really cool.
It really is. But we have to remember, this whole field is still pretty young. We're still figuring things out.
Right, of course. Like any new technology, we need to be careful and thoughtful about how we use it. Yeah. But still, it's pretty exciting stuff.
Oh, absolutely. CoE and the SN40L are pushing the boundaries of what's possible with AI. And that's a good thing. No doubt about it.
This whole deep dive has been fascinating. We've gone from like AI theory to mind-blowing hardware performance. But now I'm really curious about the real-world stuff. How is this technology actually being used to solve problems and, make a difference?
Well, that's what we're going to explore in the last part of our deep dive. Get ready for some real-world examples of CoE in action. Stuff like healthcare, finance, even climate modeling.
All right, I'm hooked. Let's do it. Okay, so we've covered the what and the how of CoE. Now for the big question. What can this thing actually do? I'm ready for some real-world magic.
Let's get practical then. CoE is showing some serious promise in, well, a bunch of fields, really. But one that's particularly exciting is personalized medicine. Like, imagine a system with expert models for genomics, medical imaging, drug discovery, all working together.
Oh, wow. So it could create like a totally customized treatment plan based on your genes and everything. That's wild.
Exactly. It could analyze your individual genetic makeup, your medical history, even lifestyle factors to figure out the best approach for you.
So no more one-size-fits-all medicine. That's a game changer. What else can CoE do?
Well, another area where it's making waves is finance, specifically fraud detection. Think about it. A system that combines expert models in, say, transaction analysis, customer behavior, market trends. It could analyze mountains of data in real time to flag anything fishy.
Whoa, it's like having an AI detective constantly on the lookout for fraudsters. They could save businesses a ton of money.
Yeah.
And headaches.
For sure. It could make the whole financial system more secure. But wait, there's more. Climate modeling is another field where CoE is showing a lot of potential.
Really? How so?
Well, you see, traditional climate models usually focus on just one aspect of the climate system, like the atmosphere or the oceans. But with CoE, we can bring together experts from all sorts of disciplines, like atmospheric science, oceanography, even economics.
So you have all these different experts working together to paint a more complete picture of the climate. That's really smart.
Right. It can help us understand climate change better and figure out the best ways to, deal with it.
This is incredible. Personalized medicine, fraud detection, climate modeling.
Yeah.
CoE seems to have a hand in, everything. I'm blown away.
And we're just getting started. As the technology keeps evolving, we can expect to see even more applications popping up.
It's crazy to think where this could all lead. Like, we talked about Samba-CoE with its 150 expert models. But what about the future? What could these systems look like down the road?
Well, it's hard to say for sure, but one thing's certain. CoE is evolving fast. It's only going to get more sophisticated, more powerful,
All right.
with even more expert models and more complex interactions between them.
So those 150 experts, that's just the tip of the iceberg.
Pretty much. Imagine systems with thousands, maybe even millions of experts, all specializing in their own tiny niche.
Millions of experts, my brain is melting. What would that even be capable of?
Well, think about it. You could have a system that can answer almost any question, solve almost any problem, create any kind of content with an accuracy and efficiency that's, well, superhuman.
It's like having all the knowledge and expertise of humanity at your beck and call. Pretty mind-blowing. Maybe a little terrifying, to be honest.
It's definitely a powerful concept. And it's not just about answering questions and solving problems. Imagine CoE systems designing products, composing music, writing novels, creating whole virtual worlds.
Whoa, okay. Now that's just getting too sci-fi for me.
Huh.
Yeah.
Yeah, it's definitely pushing the boundaries, but that's what's so exciting about this technology. It has the potential to transform how we interact with, well, everything.
This has been an amazing journey. We started with the limitations of those massive AI models, and now we're talking about the potential of CoE to, revolutionize the world. I'm convinced this stuff is the real deal.
It is. It's an exciting time to be in this field. The future of CoE is bright.
Well, thanks for taking us on this deep dive. This was a wild ride.
My pleasure. Until next time, keep exploring, keep questioning, and keep on learning.
And that's a wrap for today's episode. See you all next time for another deep dive into the world of tech and innovation.